It's just a quick recap of what we were up to last time. We had, I think we had talked about water, that it was ionizing, right? So, so we had talked about the ionization of water, right? This is what we were doing. And I told you two ions that produce H+1 and OH ions. It's an equilibrium reaction, so you take the equilibrium constant of that. And what is in large excess, so its concentration is a constant. You don't write it in the expression. So this was what we got. We got the expression for Kw, and we said that the concentration of the H+1 and OH ions at equilibrium is very less. It's 1 times 10 power minus 7 mole per dm cube, which is why Kw comes out to be 1 times 10 power minus 4 mole squared dm minus 6. And we did discuss that it's always a constant. Uh, no matter if you add an acid, the H+1 goes up, the OH ions automatically come down, but the constant remains the same. This is the ionic product of water, and we talked about the importance of H+1 ions, and I also told you that for tracking the concentration of H+1, the values are more manageable if you take the log of those values. So when we took the log of the expression, we got multiplication in log changes to addition, and so it became minus log of H+1 concentration minus log of OH ion concentration, and the negative log of 1 times 10 power minus 14 came out to be 14. And this expression became our expression for pH plus pOH is equal to 14, where pH stands for the negative log of H+1 and OH stands for the pOH stands for the negative log of the concentration of OH. And so we did a couple of questions calculating pH, I think. And yes, so we did try and calculate pH of strong acids and strong bases. And we discussed that for strong acids, you don't have much of an issue that because the acid ionizes fully. So the concentration of the acid and the concentration of the H+1 ions, they are mostly, I mean, they're kind of the same. So you don't really have to calculate, but for weak acids, this is what we were discussing, that they don't fully ionize. So they form an equilibrium. The reaction is not going to go fully forward. If you have a weak acid, like ethanoic acid, the ethanoic acid would ionize, but only partially, which means very few molecules would actually end up ionizing. So what happens in that case is, just a second. So very few molecules actually end up ionizing, and in that case, what is done is that everything would depend on the equilibrium constant, like how much it ionizes. Equilibrium constant is the ratio of the concentration of the products and the reactants. Now, this equilibrium constant would give you a lot of information about how strong the acid is. If there are a lot of products that are forming, then the product concentration would be very high, and the Kc value would be relatively higher. And similarly, if the acid doesn't really like to ionize, so the concentration of the product would be less, and the concentration of the reactants would be more. There's going to be less ionization. So every acid ionizes in kind of the same way. You pick any acid, it would lose an H+1, and it would release some negative ions. So this is what we were doing, that we came up with this general equation for acid dissociation, that any weak acid dissociating would look like this. And I also told you about H+1, that if you have a diprotic or triprotic acid which can release two H+1 ions, I told you that even those would release one H+1 at a time. So, for example, H2SO4 ionizing, you're going to think of it as two acids. First, H2SO4 loses an H+1, and then your HSO4 minus 1, it releases an H+1 ion. So, this is all that we had done previously. Just a second, let me. Now, what we are going to do now is we're going to talk about Ka. Ka is basically your Kc. It's your the one that we just discussed. That's your acid dissociation constant. So it's your acid dissociation constant. And what we mean by Ka is like every acid is going to ionize or dissociate in the same way. So Ha, it dissociates, ionizes, produces H plus 1 and an A minus 1 ion. So it produces an H plus 1 ion and also releases some ion or molecule over here. I'm going to take an example of ethanoic acid. Use that as comparison. So it's going to dissociate and produce this ion and release an H plus 1 ion. Now the equilibrium expression for this is going to be product concentration divided by reactant concentration. So it's A minus 1 concentration multiplied by the H positive ion concentration. And you're going to divide that by the acid concentration, which is Ha. So and this is known as your dissociation constant Ka. It's basically Kc of acid dissociating or Kc of this equilibrium. There's no difference to it. It's basically Kc. So for example, if I write the expression for Ka for this one, it's going to be ethanoate ion concentration multiplied by the H plus 1 concentration and divide by the acid concentration, which is CH3. So every time K is going to have kind of the same, no matter what the acid is, going to have kind of the same expression. Just briefly, talking about this equation in a bit more detail as well, although this equation could be used, but I told you that in an aqueous solution, you don't have H plus 1 ions. We did discuss this previously, like in very early on, we did discuss that in reality there is no H plus 1 ion. Whenever H plus 1 ions are produced, those H plus 1 ions are captured by water molecules. The lone pairs of water, they attract or datively bond with H plus 1 and instead you get an H3O plus 1 ion. So this acid dissociation equation is kind of it's kind of an oversimplification. Where's the equation? Just a second. It's kind of an oversimplification. Uh, But no matter if it's an oversimplification, the K expression would still come out to be the same expression. So remember this, that H plus 1 concentrations, there is no H plus 1 in water, it gets absorbed by water. So the actual or true equation is, it's going to be this one, that you're going to have ethanoic acid, and H plus 1 would be released, but that H plus 1 would be absorbed by water molecules. So it's this reaction that ethanoate ions are going to be produced. It would release an H plus 1, but that H plus 1 would be captured by water molecules. So that's your actual acid dissociation equation. So don't get confused if they're using this one. But even if you use this expression, your equilibrium constant would kind of come out to be the same thing. It's going to be product concentration into the other product is H3O plus 1. Divide that by the reactant concentration, which is CH3. COH and water. And again, because everything is happening in aqueous state, water is in large excess. I mean, there's too much water that its concentration is almost constant. So you don't write water in the expression. So I mean, adding that water was kind of pointless because you were never going to write it in the expression. So if you remove water, that is, I mean, you get kind of the same expression. So sometimes they say that Kc and the water concentration, which was a constant, combined, that's known as Ka, which is kind of the same thing. So don't get confused. It's no matter if you use this equation where you don't show H plus 1 ions, or you use this equation. In both cases, your equilibrium constant expression would kind of come out to be the same expression. So a lot of, most of the time, generally, conventionally, this equation is the one that's used. But doesn't really matter if you use the other one; it's still the same expression. Is this clear? Ethan, Minail, is this clear? Ibrar, Nabila, can you all hear me?
Yes, it's clear.
Okay. So that's your Ka expression, right? And the second thing is that these two ions are going to be they are going to be produced in these two ions are going to be produced in the same concentration because according to the equation they would exist in 1:1. Like if two molecules ionize, then two of A minus 1 and two of H plus 1 ions would be produced. So these things are always going to be produced in exactly the same ratio. So this one and this one. So both ions are going to be produced in exactly the same ratio, which means that the concentration of A minus 1 and the concentration of H plus 1, they are equal. So which means that instead of using the concentration of A minus 1, I could just substitute H plus 1 over there, and the numerator would become H plus 1 squared. So your K expression, it turns into H plus 1 concentration squared, and at the bottom it's the acid concentration. So we can just, for clarity, we can just write acid over there.
So yeah, how did H plus 1 ion became a square? I mean,
नहीं, it's ये clear है कि that A minus 1 concentration and H plus 1 concentration are the same.
नहीं ये clear नहीं है मतलब how?
नहीं, like if one molecule dissociates, ionizes, one A minus 1 and one H plus 1 would be produced, right?
Alright, ठीक है.
So
Yeah.
so whenever an acid ionizes, I mean, this ion and this ion would be produced in exactly the same ratio, right?
Yeah.
So which means concentration of A minus 1 is the same as concentration of H plus 1, right?
Yeah.
So just instead of A minus 1, just substitute H plus 1 over there. What do you get? I mean, instead of this A minus 1, you can substitute H plus 1 over there. So it's going to be H plus 1 concentration into H plus 1 concentration, which is going to make it squared. Clear?
Yes, I see. Yeah.
Actually, anyway, so your entire Kc expression for acids is now basically this. That's it. Here, that's your dissociation. That's your expression for the acid dissociation constant, and the value, or sorry, the unit is mole per dm cube. So why is it mole per dm cube? Because it's concentration squared divided by concentration, so it's obviously mole per dm, because concentration and concentrations would cancel out, and there's going to be one concentration left. So that is what K is. So every acid has a particular K, and you have calculated that. K only changes with temperature, otherwise it's a constant, because it's an equilibrium constant. So it only changes with temperature. Otherwise, it's a constant. Like you keep changing concentration, it's going to stay constant because the ratio of the products and reactants, that ratio would be maintained. And also, you should know that that higher K, like a larger K, what does that indicate? A strong acid or a weak acid?
Weak. Strong acid. I
Strong
mean,
acid.
hydrogen ion. Yes.
Because there's going to be more, I mean, there's going to be more products, right? What is K? It's the concentration of products divided by reactants, right? So if it ionizes more, if more of these ions are going to be produced, then obviously it's going to be a stronger acid. So a higher K means that there are going to be, it's going to be a stronger acid. Vice versa, a lower or a smaller value of K indicates that the acid that you're dealing with is a weaker acid. So I'm just going to show you that K values are calculated. They're not in your data booklet, but for every question, these values would be given to you. For example, I've just Googled things. So, for example, you have all these acids over here. So the K values are provided, and you can clearly see that the values are kind of sometimes they're very very small. Uh, for example, 10 power minus 14. That's a like boric 3 acid is a very very weak acid. It hardly produces any ions. Uh, but some acids would be kind of strong. I think this is a. I mean, this is coming. This is probably 10 power minus 5. It can't be 10 power 5. So every acid, by just looking at the K value, you can figure out. Whether it's a strong acid or a weak acid. For example, the HSO4 minus 1 ion, that's kind of a strong acid because the value is 10 power minus 2, which is on the higher side. It's Now, another thing is that you would notice is that again, remember we talked about representing values or how to present data. I mean, these values have a very huge range. I mean, one is 10 power minus 10, the other one is 10 power minus 5, 10 power minus 12. You can't, like, if you were to plot graphs of this, the graphs, it would be very hard to actually make a graph. So the thing is that even for K values, what they do is, and it's harder to communicate as well, like telling something 1.6 times 10 power minus 14, that's kind of difficult. So what they do is they don't usually talk about K values, they instead talk about pKa values. TK, we did talk about taking the log. So pKa stands for, once you have the Ka value, just take the negative log of, you take the negative log of Ka, and that provides you with your pKa values. so, so that's the negative log. Uh, these values would be easier to manage if you, simply because they're easy to manage. Like it's, you can see over here, I mean, all these values, they turn into kind of manageable whole numbers, 6.3, 13.8. And another thing about log is that, and we did do this, because you're putting a negative sign, the scale inverts, which means that a higher Ka value means that the
So
peak.
what is this P? Yeah, K
कौन सा?
K Ka के साथ जो P लगा हुआ है आपने.
It's a
Yeah, what is this?
pH. I mean, we did talk about this thing. Okay, we did this in pH as well, right? I mean, what is P? P is the negative of log.
Yeah,
ठीक है, we did discuss all of this. Okay, I told you
three.
like if values are really small or really big, they become more manageable if you just convert them into log, right? So remember this,
Yeah.
P stands for minus log. So even in K values, what they eventually do is they don't deal in K values, they instead deal in like they do deal in Ka values. Sometimes the question would be giving you Ka values. Sometimes it would be giving you pK values. So so it depends. But taking the negative log of Ka values, the values would be kind of easy to manage. But the scale inverts. A higher K value indicates means that your pK value is going to be a lot lower. I mean the same with H and H+1 concentration and pH. A higher H+1 concentration indicates more acidic. That indicates that the pH would be kind of really low. And a lower K value indicates that you're going to get a higher pK value. So the scale inverts when this happens. So over here, you can see that if the value is really low, 10 to the minus 13, the pK value comes out to be really high. So a higher pK value indicates that it's a weak acid. And a lower pK value indicates that it's a strong acid. Like if you go through the pK values, for example, 3.1, that's a strong acid. I mean, relatively a strong acid. You can see that the Ka value is high. This one is a really low pK value. That means it's a very strong acid. The Ka value is, it's kind of high. Uh, and the higher the pK value, the smaller would be the Ka value. 13.8, uh, the Ka value is kind of really small. So the higher the pK value, that means it's a weak acid. The lower would be the Ka value. Is that clear? So there are two ways of representing Ka values. One is Ka, the other one is you take the negative log of that. TK, is this clear?
Yes.
So now what's supposed to be done is that you have this thing. This is what you're going to use for weak acids. The questions are going to be kind of very, very simple because you just have to use this formula, that's it. They would either give you the acid constant, they'll tell you about the acid concentration, and they'll ask you about the pH, for example. So you just have to use this formula. So we're going to do one question, which is, let's say I've got 0.15 mole per dm cube of ethanoic acid. And I know the K value of ethanoic acid. Now, so I'm just going to Google it of ethanoic, probably 1.8. Yes. So ethanoic acid is 1.8 times 10 per minus 5. So, so the K value is known, already known. It's for ethanoic acid, it's 1.8. So this one is 1.8 times 10 to the power minus 5. Now, all we have to do now is we just have to plug in the values in the K expression. And they're asking us to find what is the pH of this acid. So Ka is H+1 squared, which we don't know, divided by the acid concentration. So what values do we have? We've got our Ka value, we've got our acid concentration. So we're going to use those values. It's 1.8 times 10 power minus 5. The H+1 concentration, that's completely unknown, no idea whatsoever. And you have your acid concentration, which in this case is given as 0.15 mole per. So that one is given, it's given as 0.15 mole per decimeter. So can anyone try and solve this? What do you get? H% squared is going to be 1.8 times 10 power minus 5 multiplied by 0.15. There's a square, you get rid of the square by under rooting everything. You take the under root. So where are we? What are we getting?
1.64 times 10 to the power minus 3.
So we're getting 1 point. And you've taken the under root, right?
Yes.
Achha, so we've gotten our H+1 concentration. The only thing is he was looking for the pH. So take the negative log. What's the pH now? What's the negative log of this thing?
2.78.
2.8.
78.
Because that's your pH. So just remember that just this expression, out of the three things, two things would be known. You just have to plug in the values, you'll get the third thing. So let's do another one. Now, this time in the next question, you have what's given. In the next question, what's given is, let's say, let's take another acid. Let's take oxalic acid. So I've got 0.15. No, forget. I don't have the concentration. You're supposed to find the concentration. So find the concentration of oxalic acid, which has a pH of having pH which is 2.1, and the K value is given. So we can just Google it, K of oxalic acid. So that is 5.4 times 10 power minus 2. So that value is given. So K value is known, which was I think 5.4 times 10 power minus 2. We just find the concentration of oxalic acid having pH 2.1. So just plug in the values of into the K expression, which is Ka is equal to H+1 squared, and divide that by the acid concentration. So we have the K value. You can, I mean, the K value that's already given. That's obviously there. So you put that value in. What else? The pH is given, so you can find H+1. How do you convert? How do you take the anti-log?
10 to the power of minus 2.1.
Because it's going to be 10 power minus 2.1. So that's it. So just plug in those values. It's going to be 5.40 times 10 to the. I'm going to rearrange thing. I'm going to bring the acid to the top because that's. So we're trying to find the acid concentration. It's going to be 10 power minus 2.1. That's being squared. And we're going to divide that by K value, which is 5.40 times 10 to the power minus 2. Right? So I've switched the positions of K and acid. So can you tell me what is the concentration of the acid?
1.17 times 10 power of minus 3.
Mole per decimeter cube. Is that clear?
Yes.
Is this clear? Azwa, is this clear? Nabila, Minahil?
Yes, sir.
Achha. Can you just hold on 1 second? Hello, can you hear me?
Yes.
So just this one, sorry, I had a call. So we're done with these questions, right? So I guess I mean you can't start a new topic, so you can just practice this one. Ethan Mohammed, are you there?
Yes, I'm here.
Okay, I wanted to schedule a class for A2 exam, like a past paper session, maybe a longer one. So, when can you be available tomorrow? Are you guys available tomorrow morning? Maybe.
Yeah.
Yeah, I think
Yeah, I'm free.
11. Can you manage 11?
Yeah, I think it's
The
possible.
11 my
Your
time. So
time?
that's like
1
that's.
o'clock.
Nee, acha, that's you're late, right? So nee, so we can try 10 or 10:30, right?
Yeah.
Oh, chalo, theek hai. Okay. So
Are
I'll try.
you not free at that time?
Nee, who's not free?
I'm Sohail.
Acha, you're not free. You're free at 11.
Yeah. Yeah, 11 my time.
Okay, sure. Then
Actually.
we can do 11 then.
Wait.
ठीक है?
Sir, so 11 your time, right?
11 my time. Yours would be 1 or 2 or something.
All right.
It would be 2. It would probably be 2 if it's a 3-hour difference. So
Yeah.
let's
All right.
let's continue
Okay.
next time then. ठीक है? Okay, everyone.
Thank you.
Thank you.
Adam, are you there? Just a second. Hey, Adam, when's your exam? So Adam, the chemistry one, A2 one. It's May June or so I think you should join. I'll send you the link. Okay, make sure you message me. I'll send you the link as well. So you should join this class as well. So let's continue next time. Okay, everyone. Adam, do message me. Okay, WhatsApp. Okay, take care. Allah Hafiz.
Thank you.
Thank you.